Now I'd like to discuss the way to solve a decision problem with a diagram called the decision tree. A decision tree shows all the possible alternatives, states of nature, and consequences with graphics. It consists of nodes and branches. There are two types of nodes. A decision node, it represents the point in time when you have to make a decision. It has branches that represent the decision alternatives. So it looks like this. We have a square for the decision node, and decision alternatives are represented by the branches that come out of the decision node. So decision alternatives are represented by the branches. Now, a chance node represents the point in time when someone else, other than you, make the decision, like Mother Nature, market forces, and so on. So it's a circle represented by a circle, and the branches from it are these states of nature. States of nature. When you're at a chance node, which branch is chosen depends on chance, not on you. You don't get to decide which branch to take. Now, to introduce the use of a decision tree, we'll first redo the problem we just did, the original one, this time using a decision tree. So remember that it looks like this. So here's a payoff table representing the original problem. And we're going to follow the steps outlined here. Okay, so the first step here is we draw the tree, go from left to right, and we construct nodes and branches and label them. So here we got to think about, well, what happens first? Do we make the decision first, or do we see the demand level first? Right, we make the decision first. So we start out with a decision node like this. Now there are three branches coming out of the decision node representing small, medium, and large. So let's draw those. Small, medium, small, medium, and large. Okay. Now at the end of each of these branches represents the point in time when you have already made a decision. Like here, you have already built the small condominium complex. And then now what's going to happen? Now we're going to see the demand level. Demand level will be either strong or weak. So here, demand level is a chance event. So we draw a circle for the chance node. And we draw the two branches representing strong demand. Let's call it S1. And weak demand, we call it S2. The same situation at these other branches. So we copy what we just did at the other branches. So strong weak demand, and here another pair, strong demand or weak demand. Okay, now we're going to label these nodes, maybe give them some numbers so that we could call them by their names. It's nodes 1, 2, 3, 4. Okay, so we just finished first step. Now let's go to second step. We now assign the probabilities to chance events and payoffs to the ends of the tree limb. So basically we're going to put the given data on the decision tree. So here, this is a point in time when everything has been done, and we actually see the final payoff. And the payoffs are given here, so we just have to copy down these values. So here, for instance, this is after you build a small condominium complex and the demand happened to be strong. So we have the payoff of 8 million. And here the demand is weak, so the payoff is 7. So just copy down 14, 5, 20, negative 9 at the other places. 14, 5, 20, and negative 9. Okay, now for the probabilities are assigned to the states of nature branches. That means the nodes the branches that emanate from the chance nodes, from the circles. Now the probabilities are given here, 0.8 and 0.2. So the strong demand gets 0.8, weak demand gets 0.2, everywhere. 0.8 and 0.2 everywhere. Okay. So that was a second step. Now we're going to compute the value at each node in reverse chronological order. That means we go from right to left. So we're going to process these nodes 2, 3, and 4, and then we go on to node 1. So first, let's take a look at node 2. Okay, at node 2, now what is the likely payoff? Well, it could be 8 or 7. We don't know which one. So the best we could do is just find the expected value given using the given probabilities. And we already done the expected value calculation before, so you know what to do. So here we're going to say at node 2, the calculation is you go to each branch and multiply the probability by the payoff. And then sum all the results. And then plus second branch, multiply the probability by the payoff. So this calculation we already have from our original example. We got here 7.8 was the answer. So and then we write down the answer right here, right above the node. Now this one we're going to multiply again. 0.8 times 14 plus 0.2 times 5, that gives us 12.2 as before. Here we multiply 0.8 times 20 plus 0.2 times negative 9, that gives us 14.2. Okay, so now we jump to the left to node 1. Now at this node, it's a decision node, so we don't actually do expected value calculation. We just get to choose because we get to decide here. So there are 3 choices. And first choice leads to 7.8. Second choice leads to 12.2. The third choice leads to 14.2. So obviously you want to choose a third branch leading to the highest expected value. So here is where we will go. And so if you're here, you will automatically get the highest value coming out of these 3 branches. So the value here will be the highest value out of the branches emanating from this node. So in general, when you're at a chance node, when you're at a circle, you need to calculate the expected value by multiplying probability by the payoff and then adding all the results over all the branches. When you're at a square node, you get to decide, so you just have to choose the highest value and then copy it down next to your decision node. Now, when you're done calculating the values at all the nodes, then we determine the optimal decision by following the chosen branches, that is, alternative branches that were chosen. Now here, starting from here, there is really only one decision to make, and we would go this way, build the large condominium complex, and there's no more decision after that. So that would be the answer. So we would say, here's the answer. Optimal decision is to build a large condominium complex, and from this, the highest expected value will be achieved, and that is $14.2 million. So that would be the answer. So as we expected, we end up with the same decision as before. So what we've just done is do the same thing. We already did. It's just on the decision tree. So what's the point of making a decision tree? Well, the benefit of the decision tree is you could use it to make more than one decision. In life, you often need to make a sequence of decisions. The decision you make now affects the choices you have for the next decision. For example, going to college involves a sequence of decisions. So first, you might decide whether to go to college. So you could think of it as, okay, you have a decision. Do you want to go to college or not? So go to college, yes or no. So let's say you decided to go to college. Now you have to decide which colleges to apply to. So that's another decision to make. Should we apply to colleges, A, B, and C, or A and B, or B and C, or A and C? There are many possibilities, many choices. So you're going to have, many decision alternatives. So let's say apply to, A, B, and C, or maybe A, B, and C, A, C, A, B, and so forth. Okay, now let's suppose you apply to 3 schools, A, B, and C. Now, do you get to choose any of these? Well, first you need to wait for the acceptance decision. You may not have gotten to all 3 schools. So here is now it's the admission office's turn to make the decision. And there are several possibilities. You might have gotten accepted to all schools, all the 3 schools, A, B, and C. So accepted at A, B, and C, or maybe just A and B, or just A and C, and so forth. Okay, now suppose you got accepted to, let's say, A and B. Now you have to choose. It's your turn to decide. So decision node, you want to go to A, or do you want to go to B? So which school to go to, A or B? And so forth. And once you decide which school to go to, and then you need to decide on a major, and there you're limited by the majors that are offered by the chosen school, unless you might want to transfer out. Now with the payoff table, you could handle really only one decision and one chance event. With a decision tree, you could grow it, as large as you want to represent a sequence of multiple decisions and chance events. So that is the advantage of using a decision tree. Now we'll see how to use a decision tree to model a situation when there is more than one decision to be made. Suppose PDC is now considering doing a 6-month market research study to evaluate buyer interest. It's estimated to cost $500,000. Now, at the end of the market research, the team will give a report that makes a prediction of either a favorable market, predicting strong demand, or unfavorable market, predicting weak demand. One problem is that such a prediction is not perfect. Its prediction could be wrong, but it'll give a better idea on the market condition compared to doing nothing at all. Whether to invest $500,000 to do the market research depends on the quality of the information it provides. Before, we saw that the perfect information is worth $3.2 million. Now, this market research will cost a lot less than that, that is, $500,000, so it may be worthwhile even if it doesn't give perfect information. So to help us assess how good the market research information is, we are given some probabilities. First, we are told the probability that this market research will yield a favorable report is 77%. Now, if the report is favorable, the probability there will actually be a strong demand, that its prediction will come true, is 94%. It's not quite 100%, indicating there is a small chance the prediction will be wrong. Now, if the report is unfavorable, then the probability of weak demand is 65%. So even if the report is unfavorable, it doesn't necessarily mean there will definitely be a weak demand. Notice we could write the given probabilities like this. This one we could write as P of F, meaning probability of fair report, is 0.77. Now this one is a conditional probability because we are given that the report is favorable. So we could say probability of strong demand given favorable report is 0.94. Here we are given the report is unfavorable and the probability of weak demand is 0.65. So probability of weak demand given unfavorable report is 0.65. Using these probabilities and the decision tree, we'll now answer the following questions. Should market research study be conducted? If it is conducted, what decision strategy should be followed with the information obtained? If it is not conducted, then what decisions should be made? We're going to draw a decision tree for this. Now, what will be the first node in our tree? Well, first, we need to decide whether to conduct market research. So we need a decision node with the branches, conduct market research or don't. So it would be like this, conduct market research or don't conduct market research. Now, if we don't conduct the market research, then we should just go ahead and make the decision on the size of the condo. So we're at the same situation as in the original problem, that is the one that we already solved by using a smaller tree. So we just need to copy here the small tree we already have. If we conduct the market research, then before we make the decision, we have to wait for the result of the market research. So the result will be either favorable report or unfavorable report. Do we get to choose what kind of report? No. So we need a chance node with the two corresponding branches. So predict favorable or favorable report and unfavorable report. Now, suppose we have a favorable report. Do you automatically build a large complex because we know there will be a strong demand? No, we don't know for sure. So we should still keep all our options open. So we draw branches for all three alternatives, small, medium, and large. See, small, medium, and large. Small, let's write S, M for medium, L for large. What if we have an unfavorable report? Again, that doesn't necessarily mean we'll have a weak demand. So again, now keep all our options open. Small, medium, and large. After we build a condominium complex, then we'll see the actual demand level. So we have a chance node with strong demand and weak demand following each decision alternative. So let's draw those branches. Let's see. So let's say S1 was for strong demand and S2 is for weak demand. Okay. S1, S2. Here we have S1, S2. Now the branches are starting to droop. Now we go back and number the nodes and place all the given data in our tree. Okay, so we're gonna give this one 1, 2, 3, 4. Oh, we have, okay, how about this? We renumber this as 5. Okay, so 1, 2, 3, 4, 5, and let's call this one 6, 7, 8, 9, 10, 11, and this one will be 12, 13, and 14. Now for the payoffs, we could use the same payoffs that we already have, 8, 7, 14, 5, 20, negative 9. So let's copy those down. And one more time. For the probabilities, we could use the ones that we got up here. It says probability of favorable report is 0.77, so that must be probably over here, which means probability of unfavorable report must be, well, 1 minus 0.77, so it will be 0.23 because these probabilities should add up to 100%. Now these guys don't need probabilities, but these do because they are connected to the chance nodes. Okay, now let's see what we could do here. Strong demand given favorable report is 0.94. So it says favorable report is given. So favorable report is given right here. And in that case, probability of S1, the strong demand is 0.94. So we could put that conditional probability right here, 0.94. Which means the other probability here must be 1 minus 0.94 or 0.06. Okay, now we could just repeat these here and here because the given condition is the favor report for the other sets of branches too. So let's write down 0.94, 0.06, 0.94, and 0.06. Now let's go down over here. Now the here it says probably a weak demand given unfavorable report is 0.65. So that corresponds to this part. Given unfavorable report, probably a weak demand, so that's S2 is 0.65. Okay, which means probably of the strong demand should be 0.35. And again, repeat these numbers. 5 and okay, so we have all the payoffs and probabilities we need. Now it's time to calculate values at the nodes. Okay, let's start with node 6 because we're going to start on the right and then move to the left. So at node 6, this is a chance node, so we need to calculate the expected values. So we're going to need to go 0.94 times 8 plus 0.06 times 7. So 0.94 times 8 plus 0.06 times 7, and that gives us 7.94. We're going to put it right here. Now at node 7, same thing, 0.94 times 14 plus 0.06 times 5. That gives us 13.46. In a similar way, we could calculate 8, 9, 10, 11. So I will just write down the results. You get 18.26 here. And here we get 7.35, 10, 8.15, 11 is 1.15. And now we go to 3 and 4. At node 3, this is just a decision node, so we just need to choose the highest one. There are 3 branches to choose from, so 7.94, 13.46, 18.26. Obviously, we want to pick up the higher value, go to building a large condominium complex, giving us 18.26. Okay, now at node 4, we have 3 values to choose from. The highest one is 8.15. So let's put that down. That's from building the medium condominium complex. Now let's go to node 2. Here we have a chance node, so we need to do our probability calculation again. I mean expected value calculation. So we're going to go 0.77 times 18.26 plus 0.23 times 8.15. So at node 2, let me also write it here, 0.77 times 18.26 plus then 0.23 times 8.15. So that gives us 15.93. 15.993 from that calculation. Now we're almost done. Okay, now we go to node 1 and compare the values at nodes 2 and 5. Now, but don't forget, when you conduct the research, you have to pay for this research, and the cost of that was $500,000. Okay, so to make a fair comparison, from node 2 value, we would have to subtract 500,000 and compare that net to the 14.2 million here. So the net here is 15.93 minus 500,000, which means 0.5 million, right? So 0.5 million, giving us 15.43 million. So we compare 15.43 against 14.2. Even after subtracting the cost, the conducting research gives us a higher value. So we want to go this way. So what we end up with here is the higher value, 15.43. So let's see, what is the decision? Let's follow the arrows. When you're at node 1, we want to go this way, conduct the research. Okay, and when you conduct the research, report might be favorable or unfavorable. If the report is favorable, then we build large condominium complex. If the report is unfavorable, then build a medium condominium complex. So that would be the optimal decision strategy. So let's write that down. So we should conduct research. So here's my optimal decision strategy. Conduct the research, and if the favorable report, then build large condominium complex. But if unfavorable report, then build medium-sized condominium complex. Now, what is the resulting maximum expected value from this? Is a value at node 1. So here we would say maximum expected value from all this is 15.43 million.